I like your headset, man. That's pretty cool.
Thanks.
What is it exactly? Is it like an Oculus, or is it an Apple Vision thing?
Yeah, I think it's like the Oculus VR headset.
Nice.
Zoom.
All right, so we've got I want two things out of you guys tonight, and that is one, since the ErgoHack 7 is about essentially adoption, I want to talk to you a little bit about your day job with a little known company named Zengate, right? So let's talk about adoption and Ergo. And I know that Dan is very vocal about what Zengate and Palmyra is. So I want to dive a little deeper into what you guys are doing to kind of make that vision happen with tokenizing commodities. So let's hear what your initial idea for how to accomplish that on a grand scale of that kind of was, what each of your roles are in that, and kind of what stage you're at in that. One of you start. You guys pick.
Luca, go ahead.
Yeah, I'll go first. Okay, so for me, I'm involved with so initially we had an MVP for the website. So that was like a custom, basically like e-commerce platform. And with a Ergo backend to process all of our transactions. And we also we developed our winter library to do all the tokenization and traceability for our initial onboarding. But as we try to progress and scale to a more a better version, we're looking into a open source framework called Medusa.js to develop an e-commerce platform or marketplace. And we're also making changes to our winter library, which includes modified contracts. And our library is implemented in TypeScript, so there'll be an npm library. And this includes metadata to store on IPFS.
When you say winter, as in the framework of the protocol, what break that down? What the hell is that exactly?
So winter is just the name. Is just the name I came up with.
Just the name you came up with,
yeah,
for the product essentially.
Well, the traceability library. So right now we did it in TypeScript, just because we could prototype quickly with it, and the backend for processing our transactions is written in TypeScript, so it was just easy integration. So what it does is there's one part of it is for traceability, and the other is tokenization. So traceability is when you want to, let's say you're the producer, you want to record some event that happened as you're along the processing steps of the supply chain, then you want to record that. So however you do that, you record the information in some metadata file. So in our case, a JSON, and we have our own structure for it. That's inspired by a known standard called EPCIS. And we just modified it slightly for our case, just a simpler version of it. And so that data is stored on IPFS, and then we store the content ID in on Ergo in a box. So that's one transaction on Ergo is to create that event box that stores the content ID hash. And then this also creates a token in that box called the event token. So we reference all these event boxes that we create with their token ID, the event token ID. And then the other part of it is tokenization. So once you're at the point along the supply chain where you're ready to tokenize the final product that you want to put up on the marketplace, then when the seller lists the item on Palmyra, then a transaction is created that creates a token representation of the asset. So if it's a lot of items, it'll create one token, but and the value, the amount will be equivalent to like the lot amount, like the lot units. And then whenever like a transaction happens between a buyer and a seller, then we transfer like one of the tokens to the buyer from the seller's wallet, and then the user can see it on their account, like in Palmyra, like that they own the asset. And then yeah, so that's like the word traceability and tokenization part of it.
Okay, gotcha. So essentially you have for traceability, you have one set of data, and then for the tokenization, you have many sets of tokens to reference from that lot of traceability from there. Very cool. All right, MGpai, what's your role here?
Yeah, so essentially from a high level, Luca likes to work on the architectural decisions and of like planning how stuff works and how things interact with each other, and Ergo script too. Then we collaborate on that. So I check his work, we talk to each other, we have meetings and discuss ideas and discuss what might work, what might not work. And even more specifically, what I do is I do the blockchain implementation. So I take the ideas and I make it happen. I build the transactions on the blockchain. I make it I track the transactions on the blockchain, make sure it occurs properly. And a really cool thing that we at Zengate are striving to do is abstraction of blockchain, because we personally believe that it's important not to throw blockchain directly at the users. The end users and even our clients, they really don't care about blockchain technology. What they care is making sure that they can be transparent to their customers and show exactly what is required in a trustless manner, and that this is what blockchain allows. Like, I don't know, like if we went back like maybe 20 years, when QX was younger, we'll see that most people, they probably didn't really understand the internet, how that worked. They probably didn't care as much, and that's why internet was slow to come to adoption. So as internet technology got better and you had to do like less setup and none of that like dial stuff that I hear about, I don't know.
Dial stuff
um
you've never experienced.
so like as that gets easier, there's more adoption. It's pretty simple, right? You have to be like a nerd essentially to use the internet back in the day and be good with it. And I believe that that's the stage we're at for blockchain. Like you really got to know your stuff. You have to know how to set up a wallet, keep it isolated, safe from bad actors, blah 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 blah. Like anyone's going to be overwhelmed with that. So what we at Zengate do is we take all that away. We make it as easy as possible, so you don't even know that you're using the blockchain. You get all the benefits of the blockchain, but you don't have to deal with all the bad stuff with the blockchain. With all that wallet creation and keeping that safe and hacks, and you don't need to worry about that at all because we take care of it. So what Zengate is striving to do is like a bridge between Web 2 and Web 3, and we slowly start with Web 2 components and Web 3 components, and we go from there. So what part I have in that is the abstraction of wallets. So we have a Zengate wallet, and currently it's custodial. So we have on Ergo, you have a special system with UTXOs, and UTXOs are referred to by multiple blockchains. Like you'll hear people say UTXOs for Bitcoin. On Ergo specifically, we call these boxes because it's easier to think of it conceptually. So you have these boxes, and each box contain a script, and this script is what allows a box to be locked and unlocked. And smart contracts play a role because if it's a smart contract, the box is controlled by that smart contract script. And if it's a wallet, the box is controlled by a wallet script. So that's how a very rough idea of boxes. So in Zengate, in boxes, you can also store arbitrary data saying that this box belongs to, you can like say anything like this box is MGPi's box, this is QX's box, like just for fun. Like it doesn't even need to be related to scripts. So here we have arbitrary data stored. So what Zengate does is that we hold custody of users' assets because users don't need to worry about their money at all. Like we don't want that concern for them. So in these boxes, we store that, okay, this box belongs to this user, even though in the script of the box, Zengate controls it completely. We have the information of who it belongs to in the box, so it's still decentralized in some manner because that information is publicly available. And we're not starting off completely decentralized because we want it to be a slow transition where you still get the security of the blockchain. And as users grow more comfortable, we'll have an option for them to gain more freedom and for them to actually use real wallets and all that. So that's how we're starting. So I'm in charge of making sure that that's smooth, that Web 2 to Web 3 transition occurs without the users having a really bad user experience. So we have Zengate wallet, creating all these boxes. So as Luca was mentioning earlier, the Winter protocol, what that is from a high level, of course, is a traceability standard. So we know how a commodity goes from one place to another. We want to track that. And the really cool part is each time that happens, a commodity moves from one place to another or becomes packaged, right? That's like an event, right? As Luca mentioned. So that's an event can be represented by a UTXO or an Ergo block. That's the really cool part about UTXO based blockchains. It's all there. So Winter from a high level, it works for any UTXO block based blockchain. So it can work for Ergo, it can work for Cardano, and if Bitcoin had contracts, it can even work for Bitcoin. So that's essentially how Winter works. So that let's see. So you have each box represents an event, and then you can recreate events by referencing a previous box. Now, we don't spend that box, and spend means that you use the value inside of the box. We don't spend that box. We want that box to be alive so that value stays within the box, but we reference it in a new event. That's where I said that arbitrary data within a box is super useful because you can point that event. You can say, hey, I'm event Y. Here, I'm pointing to the event before me, event X, and so on and so forth. You can keep on going in that chain, and if there's any errors, Luca and I also planned error correction without breaking that reference. So everything works really smoothly in a UTXO based blockchain, and I'm in charge of making the transactions happen.
So if these are always in unspent output transactions, are you worried about? I mean, these are boxes you're never going to spend, and they've never been spent. Are you worried? What are you going to do for storage rent in the future?
Yeah, so we actually that was one of the things that Luca and I really had to think about. So we already had that plan. Going back to that error correction things, right? No one is perfect. Like a manufacturer can make a mistake in their event logging system, and in this case, we provide the opportunity to correct that. And the way you correct that is you spend that previous event box, and in each event box, you have a token that always stays in that box. So you use that, the token is in that box, okay? Now, if you want to fix a box, amend an event that went wrong, you take that box with the token and then you create a new event box, but you send that token to that new event box. And in a normal scenario, the tokens always stay, like they never get transferred. So it's very obvious that if the token gets transferred, that means that there was a correction happening, and that's how we keep track of the corrections. And then your question is storage rent. So it would be something similar with storage rent, that we have enough in the box to allow storage rent to recreate that box, so that token will also move to a new box. And you can see on the blockchain, it's a storage rent transaction like that, because when we do an error correction where the box will need to be spent again, we have a special, like a flag in the smart contract or a register that says, oh, this was error correction compared to storage rent. So yes, we have accounted for both storage rent and error correction. They both are similar in the way they're handled.
And when storage rent activates, when that runs, it actually copies the arbitrary data in the registers. You don't have to
Yes, that is
dupes
required
everything,
by the
so you don't have to do
protocol.
everything.
Correct.
Okay.
Yeah, and Luca has something to add too. Go ahead, Luca.
Oh yeah, so just to add about the event box referencing. So in like any event, like the event usually represents like a set of output objects that are created in the event. Either they're created, so it'll be like the first event. Either like there's like some information that's like updated about those objects, but none of them like used. Or you can do like a transformation event where the objects get used to then create some new object. So, for example, you're processing like you're harvesting tea. That would be like the object creation, and then you're going to process those tea leaves to maybe, I don't know, like clean them, or then use them to then like package them. So like the packaged, like in the like the shredded tea leaves in tea bags, like that would be a transformation, because the output objects are tea bags, which are new objects unrelated to the input. So and these transformation events usually can involve objects that were created from separate creation events. So the event box can reference multiple events, not just one. So you have a traceability graph instead of just a traceability chain.
All right. So why last question here before we move on to your next thing. Why Ergo? Why was Ergo a good place to start?
Oh, Ergo.
Yeah, so
okay,
the best part about Erg is about how cheap it is at the moment because of the price. And then I mean, again, I guess that's a shallow response because it can go up in price. But Erg is still relatively cheap to other blockchains. And then, of course, UTXO is awesome, but there are other blockchains with it. Ergo is really good with contracts. Their contracts are really simple to write, and it's simple yet it's powerful. And I think that's really important because you have something like Ethereum, which also has very powerful contracts, very powerful, but they're so complex. That's the problem. It's so easy to make a mistake that you don't even know, and it gets exploited because of some like small compiler bug that no one saw from like 4 years ago. Like that's such a big. That's why all these hacks happen every month, and it's a pretty big issue. And Ergo mitigates this without sacrificing their contract complexity. It's super simple to write contracts. And then another final reason why Ergo was chosen is because of how well you can do parallelized transactions. So a couple weeks ago, I made a tweet about how Ergo can do about 21 million transfers. Or sorry, 2.1 million transfers in about $1 worth of transaction fees. 2.1 million. You can't do that with any blockchain I heard of. Because and the reason for that is because it's parallel. In one transaction, you have boxes. Boxes are what transfer value to each other. So you can do multiple box operations in one transaction, and that's the power of Ergo. And that is a huge contributing factor to why transaction fees are so little.
Luca, you have anything to add to that about why Ergo?
Why not? No, just gonna, no, I'm just kidding. Well, minting in tokens is, you do that. There's no like special fee just for minting a token, because the way minting tokens on Ergo works is, the token you can only mint one token per transaction, and the token ID is the ID of the first input box. So you do this like either in AppKit, or like you can force it in Ergo script, where you say like that this output box must have will have this token ID, which must be the box ID of the first input, and then the amount of tokens that you want to create with that token ID. So it's basically the same cost as any other like simple transaction. So it's then super cheap. Whereas on like Cardano, for example, there's like some fixed fee. It's a bit different.
So like 1.48 or something like that per.
Or 2.8 or
1.3
something
per
like that.
or 2.
Yeah.
Wow.
I don't know. I don't know.
Wow.
I have to
I
look
imagine
into
that
it.
could get expensive with like 20,000 tea boxes to mint, kind of thing. Wow.
Yeah, it's just I don't know. I have to learn about how to mint tokens on Cardano. It's a bit different, I think.
All right. Okay, so we're talking real world solutions with Ergo to help broaden adoption, and you guys are doing it, which is pretty damn cool. You and I should mention Dan, of course, Dan the man from Zengate. Thanks so much, everybody. We'll see you.
Hey,
We'll
guys.
see you during ErgoHack, and best of luck.
Bye.
Thank you.